So problem number 1, under heat and mass transfer, at an average temperature of 100 degrees Celsius, hot air flows through a 2.5 meters long tube with an inside diameter of 50 millimeters. The temperature of the tube is 20 Celsius along its entire length. Convective film coefficient is 20.1 watts per square meter Kelvin. Determine the convectivity transfer from air to the tube. So there are 4 choices here. Letter A, 900 watts. Letter B, 909 watts. Letter C, 624 watts. And letter D is 632 watts. So, solution here. Gamitin natin yung formula ng convectivity transfer, which is Q is equals to H sub C multiplied by the area and multiplied by the change in temperature. So, T high minus T low. Yung area dito, since may involved na tube, gagamitin natin is pi dl, where pi d is our circumference. Okay? Yun yung magsisilbi nating width, yung ating circumference. So, for convectivity transfer, substitute natin yung mga values na given. So, H sub C is 20.1 watts per square meter Kelvin. For our area, we have pi multiplied by d, yung diameter natin. So, sabi dyan, may diameter kang 50 mm. So, convert natin into millimeters, into meters rather. So, magiging 0.05 meters na lang siya. And multiplied by our length, which is 2.5 meters. And then, we have our change in temperature. So, since change in Kelvin is equals to change in degree Celsius, so no need na mag-plus pa tayo ng 273 sa kada temperature natin. Kasi, absolute temperature na sila. Okay? So, 100 minus 20. So, para na rin Kelvin yan. Yung change niyan ng degree Celsius niyan. So, cancel natin yung mga magkakaparehas na units. Kelvin, square meters, tanggal. Yung matitira natin dyan is yung unit natin is watts. So, magiging sagot natin is 631.5 watts. So, closest sa letter D. Okay, which is 632 watts. So, now we proceed to our problem number 2. So, for our problem number 2, heat is transferred from hot water to an oil in a double pipe counterflow heat exchanger. Water enters the outer pipe at 120 degrees Celsius and exits at 55 degrees Celsius, while the oil enters the inner pipe at 26 degrees Celsius and exits at 65 degrees Celsius. Compute the log mean temperature difference or LMTD. So therefore, choices here again. Letter A, 42.80 degrees Celsius. Letter B, 46.20 degrees Celsius. Letter C, 40.62 degrees Celsius, and letter D is 42.06 degrees Celsius. So, solution here. Recall muna natin yung ating TL diagram. So, i-drawing ko lang sa gilid. So, TL diagram represents for the relationship of the temperature and the length. So, the higher the temperature, the longer the length na mag-exist. Okay? So, ilapat natin yung mga given. So, sabi dyan, yung water daw galing ng 120 papunta ng 55. So, let's imagine na dito galing si 120 sa part na to at pababa siya. So, yung arrow pababa, papunta siya ng 55. So, naka-degree Celsius sila. Yan. And then, yung isa naman daw, yung oil naman, enters the inner pipe at 26. So, limbawa dito si 26, pagpalagay na lang natin. So, 26 degrees Celsius, papunta siya sa 65. So, imagine dito si 65. So, 65 degrees Celsius. So, ang kukunin natin dyan na Tmax and Tmin is yung magiging difference dung dulo-dulo nila. So, check natin. For example, yan, si 65 dito. Tapos, yung pagitan na to, yung gap na yan, dyan tayo kukuha ng mga delta Tmax and delta Tmin natin. Okay? Pero, ilapat na natin sa pinaka-formula. Pinaka-formula natin is for the log mean temperature difference or LMTD, we have the formula delta T max minus delta T min all over ln ng delta T max over delta T min. So, LMTD, delta T max, makikita mo naman visually, o kahit i-compute mo sa isip mo, kung alin dyan yung mas malaki ma-obtain na value. So, para sa akin, yung 120 minus 65. So, yun yung magiging delta T max natin. So, mas mataas na change. So, 120 minus 65, tapos may minus sign ka pa, and then yung change nung isa naman. So, 55 minus 26. Lahat yan naka-degree Celsius. Okay? And then, ln ng delta T max, which is 120 minus 65 over yung T min natin, delta T min is 55 minus 26. So, tanggal na yung degree Celsius kasi ratio yung dalawa sa loob. So, magiging final unit mo is naka-degree Celsius. So, therefore, kung isosolve mo yan sa cycle, ang lalabas sa sagot ng LMTD mo ay 40.62 degrees Celsius. Makikita mo siya sa letter C. 40.62 degrees Celsius. So now, we proceed to our problem number 3. So problem number 3, the forced convectivity transfer coefficient for a hot fluid flowing over a cold surface is 225 watts per square meters degree Celsius for a particular problem. The fluid temperature upstream of the cold surface is 120 degrees Celsius and the surface is held at 10 degrees Celsius. Determine the heat transfer rate per unit surface from the fluid to the surface. Okay? So let's solve for this problem. So solution for this. So may keyword tayo dyan. Convective. So, gamitin natin yung formula ng convection. So, Q convection will be yung heat transfer coefficient natin, H sub C. H sub C. So, dapat subscript yan. Multiplied by delta T. Okay? So, check natin. So, Q convection, H sub C natin, makikita nyo, meron naman ng binigay na 225 watts per square meters degree Celsius. Multiplied mo na lang siya sa delta T. So, yung delta T mo, sabi ko nga kanina, ang change in absolute temperature is equal sa change ng arbitrary. So, yung change ng degrees, ng Kelvin mo, rather, is equal lang siya sa change ng degree Celsius. So, walang kaso kung hindi natin ipa-plus 273 yung ating mga temperature dito. So, magiging 120 minus 10 na siya. So, degree Celsius yung change. So, cancel out si degree Celsius. Matira, watts per square meter. Bakit nga ba wala tayong given na area? At bakit sinolve natin siya ng H sub C na minultiply lang kay delta T? Kasi kung makikita nyo, ang hinihingi sa atin sa problem ay heat transfer rate per unit surface. So, ibig sabihin, merong denominator na area. So, since walang binigay na area, automatically, ang magiging unit mo dyan is watts per square meters. So, kapag sinolve mo yan, ang lalabas na heat of convection natin na naka per square meter is 24,750 watts per square meters. So, ito ang ating final answer. So, doon natin siya makikita sa letter D. Okay? So, let's proceed to problem number 4. So, problem number 4, a counterflow heat exchanger is designed to heat fuel oil from 45 degrees Celsius to 100 degrees Celsius, while heating fluid enters at 150 degrees Celsius and leaves at 115 degrees Celsius. Calculate the arithmetic mean temperature difference or AMTD. So, 4 choices here. Letter A, 40 degrees Celsius. Letter B, 50 degrees Celsius. Letter C, 60 degrees Celsius. And letter D is 70 degrees Celsius. So, bukod sa paggawa ng TL diagram, pwede tayong gumamit ng tabular na technique. So, solution para dito, we must know first the formula for AMTD. So, AMTD, arithmetic mean temperature difference, is just the summation of the delta T max and delta T min and will be divided by 2. So, kung gamitan mo ng tabular, doon ka muna sa part ng oil. So, yung oil is from 45. So, ito yung ating 0.1, sabihin natin. And then, this is 0.2. Kung gagawa mo ng table yan. Meron kang oil at meron kang fluid. So, sa oil, from 0.1, 45, papunta ng 100. Naka-degree Celsius yan parehas, guys. Yung fluid naman, galing naman ng 150. Fluid enters at 150 and leaves at 115. So, basahin mo rin pala muna yung problem. Sabi kasi counterflow. So, pag counterflow, meaning, magkaiba yung o magkasalungatan sila. So, kung ilalapat mo, yung 150, dapat dito siya. Sa tapat ng 100. Papunta siya ng 115. Okay? Kaya, kung kukunin mo yung delta T max and delta T min, malalaman mo na kagad. So, yung delta T max, pag pinag-minus mo si 115, tsaka 45, alalabas dyan is 70. Kaya 150, tsaka 100, alalabas dyan ay 50. So, yung delta T max natin, yung 70 degrees Celsius. Yung delta T min natin is 50 degrees Celsius. So, gamitin na natin si formula ng AMTD para dyan. So, AMTD is delta T max, so 70 degrees Celsius plus 50 degrees Celsius divided by 2. So, magiging kasagutan mo for AMTD will be 60 degrees Celsius. So, this is our final answer for this problem number 4. Okay? So, we proceed to our last problem number 5. So, for our last problem number 5, a counterflow bank of boiler tubes has a total area of 900 square feet and its overall efficiency of heat transfer is 13 BTU per hour square feet degree Fahrenheit. Calculate the heat transferred if the LMTD or log mean temperature difference is 1380 degree Fahrenheit. So, 4 choices again. Letter A, 16,146,000 BTU per hour. Letter B, 17,147,000 BTU per hour. Letter C, 18,148,000 BTU per hour. And letter D, 15,145,000 BTU per hour. So, solution, we have formula for the heat transfer kapag involve ang LMTD or log mean temperature difference. So, since meron kang overall coefficient of heat transfer, gamitin natin yung formula na U na malaki multiplied by the area times the LMTD. So, Q is equals to UA LMTD. Substitute the values. So, we have 13 BTU per hour, feet squared degree Fahrenheit, multiplied by the area, which is 900 square feet, and then multiplied by the LMTD, which is 1,380 degree Fahrenheit. So, cancel out natin yung magkakapares na units. Yung degree Fahrenheit, tanggal. And then, yung ating square feet. So, magiging final answer natin is 16,146,000 BTU per hour. So, this is our final answer for this problem. So, letter A. Ito yung ating sagot. Okay? So, maraming salamat sa panonood. So, nawa may tutunan kayo sa ating tinalakay na mga past board exam problems under the subject heat and mass transfer. So, this is Engineer Jom Digia. Maraming salamat sa panonood and God bless us all.